Hello friends, in today's video I'll explain the difference between an ACB and a VCB. First, you need to understand what an ACB is. Where is it used, right? First, you need to understand the input and output of a transformer. The transformer's input has an RY, and the output has a neutral RY. The output is 440 volts, and the input is 11,000 volts, right? There's 440, 433, or 410. Whatever your output is, that's where the ACB is installed, right? The AC also connects to the transformer's output. This is a basic thing you should know, right? Look, neutral RY is your neutral RY, right? This is essential in every plant. Suppose you have a 4-pole AC installed, so you can run a motor with it. If you need a neutral, you can also use a neutral. That means your ACB will be used there, okay? And now, let's assume we're talking about VCB. Now, there's a link between the VCB and the transformer. Now, what will that link be? The ACB and the transformer will be connected in that it's plugged into the output. And what is a VCB? It's plugged into the input. Look, for the input, you need to know where the 11 kilovolts transformer is coming from. And you also need to know where the 440 volts is coming from, okay? The VCB connects to the input of the transformer. Look, it's written, isn't it? So, connecting to the input means R, Y, and B, okay? R, Y, B, okay. So, if it's plugged into the input, the breaker on the 11,000 volts becomes the VCB. The breaker on the 440 volts side becomes the ACB, an air circuit breaker, a vacuum circuit breaker, okay? So, this is the first thing you should know. Once you understand where your breakers are located, you'll have a lot of knowledge about them, okay? Now, the second thing is, I've already told you about the difference between 440 and 11 kilobytes, and it's used in 11 kilobytes, VCB, okay? So, you won't be confused about this because I've already told you about it, okay? So, don't be confused about this. If you're confused about anything, please comment. Please subscribe to my channel. So, next comes your 3, 4. Look, you should know about neutral direct. Why is it called neutral direct? Suppose I have a breaker. It has R phase, Y phase, and B phase. For example, I have a TP. I have a triple pole MCB, okay? I don't have a neutral in it. So, if I have a triple pole MCB with a neutral, I'll use it directly, okay? So, that means I'll use the neutral directly. Instead of that TP, I have a 3-pole ACB, okay? For example, you already know about a 3-pole ACB. RB will be the neutral direct. There will be a bus bar directly next to the neutral. Now, let's say I have a 4-pole TPN. They call it TPA, triple pole with neutral, okay? Instead of that, instead of 4-pole, I have a 4-pole ACB, air circuit breaker RYB neutral. In this, the neutral is not direct. In this, the neutral is already connected to the ACB, okay? So, if the ACB is switched on, the neutral will also turn on and off along with it, okay? So, there's no direct neutral in this. So, you get a 3-pole ACB with a 4-pole ACB, okay? Now, let's talk about VCBs. What is a VCB? It's available in 3 poles. Why is it available? First, let me tell you about the 3 poles. 3 poles. One pole will be R, the second pole will be Y, and the third pole will be B. Now, a transformer is producing a 440 volts output, okay? But what's at the input? 11 kilobytes. The input is in delta connection, and the output is in star connection, okay? Now, 3 poles in this condition means, if your transformer is 66 kilobytes by 440, then your AC will also be connected, but the VC will also be 66 kilobytes. You should also know this. You can always say 3 poles, VC, CB, and you can always say 3 poles are gone, okay? There's no need for confusion in that. There's a little confusion in ACB, okay? And now comes the motor. Look, the motor is in our ACB. Where we talked about electrical, our ACB is already electrically charged. So, that means there's a motor there. Now, regarding VCBs, there's a motor in them too. This is a common feature between them. VCBs, for example, have a number of different types of VCBs, such as chromator, cider, Seamus, AB, and many others. If there's an electrical breaker, there's likely a motor, right? So, ACBs also have this. It's the same thing. There's no difference. Now, there could be a difference. Under voltage. If there's an under voltage in an ACB, suppose my ACB is under voltage, it's also there in a VCB. Look, that's the customer's requirement. If you want an under voltage breaker, right? So, if you need an under voltage breaker, you can also install an under voltage in a VCB, right? Now, that's settled. Does your ACB and VCB have under voltage? Both have under voltage. Now, what does under voltage mean? Under voltage means if the voltage drops or if there's no voltage, your breaker will trip, or it's used in interlocking for under voltage. Let's move on. The closing coil, CC, is present in both your ACB and VCB. This is also common. Suppose I don't want to turn on the breaker with a push button, but I'm turning it on with TNC. This means I'll turn the rotating switch on the outside to close, and it will turn on. So, it has a closing coil. Electrically, it's a breaker. So, the VCB also has TNC. Look, you need to install TNC here. So, there are many things. So this is a common thing. And then there's the ACB. Look, the ACB now has a shunt coil, a trip coil, and an opening coil. Okay, now this is an opening coil, a trip coil. What do they all have? These three names are the same. If you ever read a drawing of an electrical panel, you'll see it written somewhere as opening coil. Somewhere it says trip coil, somewhere it says shunt coil, and somewhere it says shunt release. Okay, so this is common to both. The same applies to both ACB and VCB. It's for off and trip, meaning you need to trip the breaker through a PLC. That can also be done through this. So now we're talking about EDO, MDO, EDO, and MDO, right? EDO means electrically, and MD, MDO, and the first letter, M, is manual, right? So, both have ED and MD in VCBs, and electrically in ACBs. Now, there's no difference between them. Both have ED and MD. Drawout means, for example, I need to perform maintenance on a breaker. I need to remove the breaker, place it on a table, service it, then, I need to reinsert it back into place. Whether it's the main breaker, the outgoing breaker, or the motor breaker, right? Even if it's a DG breaker, there's an electrical drawout. How did it happen? There's an electrical drawout. Now, if that draw breaker, I'm calling it, has a motor and a closing coil, then that means there's an electrical drawout. Okay? Now, what's the difference with the third element? EF and MF. Look, these are EF and MF. EF and E, I've already explained E, and I've also explained the meaning of M, and F means fixed. Fixed means the thing is connected right there. We can't move it. If I need to service it, I need to cut off its input supply. I need to cut off the busbar supply. I need to earth the busbar, and then you can service it there. Okay? After cutting off the supply, I need to earth it. After earthing, I can touch it. Okay? For maintenance. Otherwise, don't take any risks because it's a fixed breaker. Look, it costs you less money initially. Okay? But what happens? The difference is that the maintenance time is longer because you have to take a previous shutdown. You'll have to cut off the entire busbar's supply before you can service the fixed breaker. Okay? Because the input poles will have supply. How can you service it? Okay, now, the VCB. Fixed breakers are also available in VCBs, but you'll rarely see them. In other words, they're rarely installed. They're installed in such a small percentage of cases because, look, the maintenance of an 11 VCB is much less than that of an ACB. Okay, now, what happens with our VCB is that if we install a fixed one, it means I'll have to cut off the supply at the back. This means that this VCB has two terminals, input and output. The input side is also coming from 11. The output side is also going to 11. Okay, now, I'll have to cut off the input supply. First, only then can I touch it. How do I do that? I'll have to earth it first. Okay, now, let's assume this breaker is the input, and this breaker is the outgoing one. Its input breaker will have to be closed first. Now there are 3 more breakers between that input and the outgoing breaker of the output. When those 3 breakers are closed, then only there is the 4th breaker. So this means my supply of all the 4 breakers will be cut. Okay, so this becomes a bit costly. At that time the timing cost is more in its EF and MF. Okay friends, please subscribe my channel. If you have any doubt in this then please do comment, and in future I will bring more such videos for you. Okay, my channel's name is Practical and Theory. Please subscribe my channel. Thank you for watching.